Welcome to this explainer. Today we're going to demystify the massive, power-hungry machinery operating behind the scenes of the cloud. I mean, you hear terms like the cloud or AI all the time, right? But what physically happens when you actually hit enter? Well, we are going to track the literal, physical journey of a single keystroke to understand exactly how data centers move your data. It's a seriously fascinating trip that turns some pretty abstract concepts into very concrete realities.
So, here is our syllabus for today's Data Center 101 tour. We'll be covering the journey of a keystroke, the librarian versus the factory, inside the data center, the token assembly line, making the return trip, and we'll wrap up with the hunt for megawatts.
All right, let's jump right into part 1, the journey of a keystroke. Let's follow the data.
We'll start with a simple question. Imagine you're typing into your computer. How do we become the safest city in America? The exact millisecond your finger presses that key, your data starts changing delivery trucks. You see, you aren't just sending a digital letter, you're triggering a physical chain reaction. Your finger mechanically closes a tiny electrical switch. Instantly, your keyboard creates a coded burst of electrons, literally just ons and offs. Your computer hands that off to your router, and then your router does something absolutely incredible. It converts those electrons into actual flashes of light, which are then fired down a strain of glass fiber that's about the width of a human hair.
Now check out the sheer speed of this journey. We always hear about the speed of light in a vacuum, but in glass fiber, your data travels at roughly 2/3 of that speed. So that is roughly 124,000 miles per second. Literally, in just 1 second, your question could lap the planet 5 times. If your server happens to be 100 miles away, the travel time is basically 1/1000th of a second.
Just let that sink in for a moment. To put that into perspective, a human eye blink takes 300 times longer than your data traveling 140 miles to a regional server. Your question actually spends more time waiting for your physical finger to come off the plastic key than it spends crossing the state. So if you're ever sitting there waiting for an answer to load on your screen, you know the wire is definitely not the holdup. Think of the wire like an empty country road. All the waiting actually happens at the destination.
Which brings us to part 2, the librarian versus the factory. So, where does this data actually go?
When those flashes of light actually arrive at their destination, what happens next depends entirely on who exactly you're asking. There's a really stark contrast between the two main types of digital destinations. Think of door number 1 as the librarian, kind of like a traditional Google search. The librarian quickly matches your words against an existing, pre-read catalog. It just fetches an answer that already exists, and it uses almost zero energy to do it, about 0.3 of a watt-hour. But door number 2? That's the factory. That's an AI system. It doesn't fetch. It uses massive industrial scale to manufacture entirely new responses. It composes from scratch, which is a completely different physical process.
Moving on to part 3, inside the data center. Time for a quick factory tour.
So your flashes of light have arrived at the factory. Your data turns back into electrons and basically walks onto the factory floor. Now, we constantly call it the cloud, but it is a very real physical building. And these places can range from the size of a single football field to structures measured in literal miles. If you were to walk inside one of these massive buildings, you'd quickly realize the actual computing is the smallest thing happening in there. The building is fundamentally a massive electrical panel and HVAC system, built specifically to keep the machines from overheating. You've got an electrical system drawing megawatts of power, mechanical systems featuring industrial liquid cooling radiators bolted right onto the chips, and a control system with thousands of sensors monitoring the temperature around the clock. Because every single watt that comes in as electricity leaves as heat, and managing that heat is basically the facility's main job. Now, inside those humming server racks is the actual hardware crew. First, you have the CPU, which acts as the foreman, just running the place. Then you've got the GPUs. These are the line workers doing all the heavy lifting and intense arithmetic. High bandwidth memory, or HBM, acts as the workbench, keeping all the necessary parts right within arm's reach. And finally, optics act as conveyor belts of light lacing all the racks together. It's funny, history definitely has a sense of humor here. Those GPUs, the incredibly expensive, critical line workers driving our modern economy, well, they were originally invented just so teenagers could shoot zombies with better graphics.
All right, part 4, the token assembly line. Let's see how we actually manufacture words.
So, our question has finally reached the cutting station inside the factory. Like any manufacturing plant, the AI needs to standardize its raw materials. Here, that raw material is called a token. Just like drywall is billed by the square foot, a token is just a number from a fixed catalog that allows the factory to measure and, sell language. For example, the word city might just be catalog entry 913. The machine doesn't actually read English. It reads a short list of these numbers. So the token is the basic bookkeeping unit of this whole operation.
Here's how that assembly line actually moves. First, your question is chopped up into those numbered tokens. Second, that list of numbers gets multiplied and added against billions of stored pattern settings that the AI learned during its training phase. The machine executes billions of arithmetic operations at a scale literally no human could finish in 1,000 lifetimes. And what is the result of all that insane math? It drops exactly one single, most likely next token. Just one. And then, it runs the entire line again for the token right after that.
Which leads us to part 5, making the return trip. The data heads home.
Okay, so the answer has been manufactured, one token at a time. But now it has to move all the way back to you. So it swaps delivery trucks once more. It goes from a catalog number to a word piece, back to electrons, to flashes of light, and finally back to glowing pixels on your device. So the next time you see an AI generating text word by word on your screen, you now know it's not just a cute typing animation. No way. You are literally watching a live industrial assembly line shipping manufactured parts back to you in milliseconds, the exact instant they come off the line. How cool is that?
And finally, part 6, the hunt for megawatts, how we power the future.
So the physical travel time for all of this data movement was completely free, taking barely 0.02 of a second. But that brings us to the massive financial costs of the manufacturing process itself. If we look at the wholesale counter where businesses actually buy AI capacity, economy models cost about 10 cents per million tokens. But premium, highly complicated models, those cost up to $50 per million. The tokens coming out cost 3 to 6 times more than the tokens going in. Producing new tokens is an incredibly expensive manufacturing phase, and it's driven purely by the physical limits of computation.
But here's a reality about those costs that might actually surprise you. The electricity to answer a single question costs mere fractions of a penny. So the spread between the power bill and the token price looks pretty enticing, right? Well, until you realize the factory's real expense. The industry actually has to constantly borrow massive sums of money to replace wildly expensive, specialized chips every 3 years when they become obsolete. That is the true hidden cost of moving and processing all this data.
And because your data can cross the country faster than a hummingbird's wing beat, these factories have a very unique real estate checklist. Honestly, they don't care where you live. Proximity to customers is completely irrelevant. What they are purely hunting for are cities with spare megawatts on their local power grid, heavy fiber trunk lines, and a cool climate to help lower that massive cooling bill we talked about. Power is the ultimate bottleneck for this entire industry.
At the end of the day, despite the incredibly futuristic output, the operators of these massive buildings are essentially just industrial landlords. They secure the power, they run the cooling, and they lease capacity to tech companies who bring in their own machines. If you strip away the sci-fi glamour, it's really just real estate attached to a massive electrical substation.
Which leaves us with a final thought to ponder. As these data centers look to expand into our local communities, constantly hunting for those spare megawatts, the debate isn't actually about technology at all. It's about resources. The factory can manufacture a perfectly fluent answer to saving a city in 4 seconds, but the will to act on it remains entirely local. Leaving us to ask, at what price are we willing to sell our hometown's electrons to fuel this massive data movement? Are we truly ready for the physical realities of the sentence factory? Thanks for joining me on this explainer. I hope you now have a rock-solid understanding of exactly how your data moves.